All right. So the other day we talked about Bohr diagrams. Okay. And when we were talking about Bohr diagrams, we drew the nucleus and then we drew the rings. And once we drew the rings, we put all the electrons on the rings. Okay. So how many electrons can the first ring hold?
Two.
Yes, two. Very nice. Okay. And then anybody remember how many the second and the third ring hold the same amount? Anybody remember how many those hold?
8.
8.
Eight. Very nice. Okay. So when we talk about those, okay. So I'm going to give you a little bit of background, and we're going to talk about this more in depth later on. Okay. But when we draw a Bohr diagram, so for example, um, let's say we drew one for carbon 13. Okay. So I had a carbon 13. Okay. And remember, we always say we figure out our protons, neutrons, electrons, and then the rings. Okay. And I'm going to kind of fly through this one today. Okay. So, because we should be kind of used to it. Well, somebody tell me how many protons first. That one we should know. Six. Very nice. All right. Carbon is number six on the periodic table. There's nothing indicating that there's a charge. So, what else is also six? Very nice. Electrons is also six. Okay. This is my mass number right here. So remember, mass number is protons and neutrons. Okay. So oh, that looks crazy. Protons and neutrons. So if I subtract protons from that number, I get seven. That's how many neutrons it is. And then somebody tell me how many rings carbon should have?
2.
Two. Very nice. It's on the second one. All right. So when I draw my Bohr diagram, I would have a nucleus. P is equal to 6. N is equal to 7. Two rings. 1, 2. First ring can only hold 2 electrons. I got 6. So here's 1, 2. I need 4 more so I can get to 6. 1, 2, 3, 4. That's 6 total electrons. 6 total. Okay. You don't have to color them in. Sometimes I do color them in. Okay. All right. So when we talk about atoms, okay, somebody remind me, what is it called when two or more elements combine? I think way back to this one. What is it?
Mixture or colloid? One of the two. I forget.
Oh, you're close, but you're on the other side of the diagram. So we need to be on the other side. So you do have mixtures, and under mixtures you have colloids, solutions, and suspensions. But we're on the other side. So you had atoms and then two or more atoms combined.
A compound.
Very nice. A compound. Okay. So that was impressive, Ryan, that you remember the other side though. Okay. A compound. So when we start, let's be real, like most of the stuff we deal with in the world is a compound or a mixture. Okay. So mixtures are mixtures of different compounds. Okay. Or maybe like a compound in an element. But a lot of the stuff, like we don't see, for instance, we talked about just sodium, okay? Like if we're talking about table salt, okay, which is NaCl, okay, it's sodium and chlorine combined, okay? Now, here's the new part. When we are combining those, okay, when we're combining those and we're looking at the atom of it, nothing in the nucleus changes, okay? So when I look at sodium and chlorine put together, sodium's nucleus stays the same, chlorine's nucleus stays the same. The important part is the electrons, because that's how they kind of like attach to one another. Okay, that's how they attach to one another. So the reason why Bohr diagrams are important is because now we get to look and see, oh, let's look at the electrons. Now, the electrons on the outermost ring, okay, the outermost ring are called valence electrons, okay? So when we start putting stuff together like sodium and chlorine or hydrogen and oxygen to make water, okay? The only things that's changing are these electrons on the outside, okay? So the electrons on the outside, they're called valence electrons, okay? Valence electrons. So it's important that we know how many valence electrons an atom has, because that's what we're going to kind of start using when we start putting stuff together, okay? So an easy way for us to know how many valence electrons we have is to do a Lewis dot diagram, okay? It is helpful because we start using Lewis dots to show electrons either moving or being shared, okay? So that's the two ways you can stick together. You can either say, hey, I don't want this electron, you can have it, okay? Or we can say, hey, let's share electrons, okay? So a Lewis diagram is a shorthand of a Bohr diagram, okay? So remember, Bohr diagrams is what we just did. So this is an even shorter version, okay, of a Bohr diagram in which only, okay, the valence electron, I'm going to shorthand electron, but you can write it out if you want to, are drawn as dots. Okay. All right. So now we're going to go from having this circle, you know, with the nucleus and then the different number of rings and then all these electrons on the outside, to just showing how many electrons does this element have just on his outermost ring. So remember, the outermost ring is going to be the ring that is furthest away from the nucleus, okay? The one that's closest to the nucleus, we call it the inner ring, okay? Now, valence electrons are the electrons on which energy level or shell or ring? Which one did I say? Valence electrons are on which ring? Or yes, the outermost, okay? So in this case, yes, it's the second one, but it's the one that's on the outermost ring or energy level or shell, okay? And the only reason in this case it is the second one, but the only reason I didn't say the second one is because maybe you have 3 rings, or maybe you only have 1 ring, or maybe you have 4, okay? So it's the one on the outermost ring or energy level or shell. Remember, all those words mean the same thing, okay? All right, so this is how easy it is to do a Lewis diagram, okay? The first thing you're gonna do is you're gonna write the element letters or the symbol for the element, okay? Where can you find the symbol for an element? On the what?
Protons.
On the what's the thing, what's that thing we use all the time? Somebody online tell me. What's the sheet I said you're gonna need for the rest of the semester?
Chemistry cruncher.
Chemistry cruncher.
Very nice. The chemistry structure is our periodic table. So you're right. I just got a brand new periodic table for you guys too. It is huge. I'll show it to you guys in a little bit. You guys, I'm so excited. Like Christmas. Way better than that. I'm gonna hang it up. Oh, there it goes. All right. I'll show you guys my periodic table in a little bit, okay? All right. So this is how we determine. So here's the good thing. The periodic table, I can't wait for us to do this unit because it's one of my favorite units, because it's crazy how much these people were able to organize the periodic table. Like, there's all these systems of organization to it, like besides them just being listed in order, okay? So here is the great thing. To determine the number of valence electrons an element has, so I'm on number 2, okay? You're gonna count what number column the element is in. You're gonna start from the left, okay? So you're gonna go from left to right. Now, we're gonna skip the middle ones, okay? So the ones where they dip down, we're gonna skip these, okay? All right, so it's already listed for you. This time we're doing columns though. All right, columns, left to right or up and down? Which way do they run? So you have columns and you have rows. Which one do you think columns goes which way? Very nice. Columns go up and down, okay? So here we have column 1, and you have column 2. You don't have to draw these arrows. I'm just showing you. So this is column 1, column 2, okay? Then you skip the ones that's down here in the valley, okay? And then 3, 4, 5, 6, 7, 8, okay? So when we look at this, okay, we call them columns, or we'll find out later on that they're also called groups, okay? They're also called groups. All right. Okay, so now we have, we found the element, okay? So it says write the symbol for the element. So let's just do carbon, for example, okay? The carbon, the symbol for carbon is what? Very nice. C. All right. So number 3 says, okay, and I think if I scroll, my writing's gonna go with it, so I'm gonna probably have to wait. Let's see. I'm gonna see if I can fill in. Yep. Okay. I'm gonna see if I can fill in 3, and then we'll go from there. Okay. All right. Okay. So number 3 says draw the number of determined dots around the symbol. Okay. We're going to do our dots just like we did for our blurb diagram. So we're going to start at the top. All right. And then rotate around the symbol. Last time, did we go clockwise or counterclockwise? We went clockwise. So we're going to do the same thing in a clockwise direction. Okay. And then if you have more than 4 dots, oops. If you have more than 4 dots, then you should pair the remaining dots, which is no different than what we were doing before, right? So remember we would say, we would start at 12 o'clock, then we would go to 3 o'clock, 6 o'clock, 9 o'clock. And then if we have more than those 4, we would go back to 12 o'clock, back to 3 o'clock, back to 6 o'clock, back to 9 o'clock, okay? All right. Now, here's the great part, okay? And this is something that you want to make sure that you note, okay? This is really important and can save you a lot of time. Make sure you pay attention to the fact that everybody who's in the same column or group or family, that's another word we could use, okay? Okay, because they're called families. Everybody is going to have the same Lewis dot. Okay, everybody's going to have the same Lewis dot. Okay. All right, so I want you to find carbon, and somebody tell me based off of what column or group or family that is in, how many dots should it have? Somebody online tell me, because these guys in here are answering. They know all the answers. They're smart. So somebody online, find carbon. Tell me how many dots you think it should have.
4.
Yes, it should have 4. All right. So if carbon has 4 dots, it says start at the top, then rotate around. 1 dot, 2 dots, 3 dots, 4 dots. The end. That's it. Okay. Somebody tell me, okay, another element that is in the same group or column or family as carbon. Somebody tell me another one that's in the same column as carbon. Tell me another element. I can call on somebody. Let's see. Josh, can you tell me another element that's in the same group, column, or family as carbon? Are you there, Josh?
Say it again.
I would like to know another element that's in the same column, group, family, whatever you want to call it, as carbon.
I was about to say, I gotta turn on my periodic table.
Okay, do you want to Fine. Or you can look at this one right here, right? Can you see this one?
Not really, but column. I can say silicon.
Yes, silicon is also in the same group family column as carbon. It is right under carbon, actually. So how would I do the Lewis dot diagram for silicon? What's the first thing I need to write?
You gotta write the rings.
Nope, that's Bohr diagram.
Oh, my bad. The protons.
Not quite. We're on Lewis dot. So we're looking at these directions. Danielle, Daniela, do you know the first thing I need to write? I'm doing a Lewis dot diagram for silicon.
You have to write the SI.
Very nice. SI, that's the symbol for silicon. Very nice. Now this is in the same family group column as carbon. So guess what? It should look the what? The same. So it's going to be 1 dot, 2 dot, 3 dots, 4 dots. Boom, same thing. Okay. Every single one in that same family, okay, is going to have the same Lewis dot diagram. Okay. All right, let me save this. I'm going to clear this screen off, okay? Or at least clear off some of it. All right. This is what I want you to do. Wherever you are in your notebook, let me erase some of this stuff. Or let me zoom down. All right, so there's some down here. There's one from each family, okay? I'm going to erase this. Okay, so there's down here, it says, draw the Lewis dot diagrams for the following elements. Actually, you know what? Let's make this an assignment. This is an easy one, okay? All right, so this says draw the Lewis dot diagram for this family on a sheet of paper, okay? I want you to write each one of these: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, okay? And you're gonna do the Lewis dot diagrams for these, okay? They should be fairly easy. They should not take you long. I'm about to make a Schoology assignment. You're gonna submit it and turn it in. And if you, I'll give you about, say what, I'll give you 20 minutes because it should take you about 10 minutes to do it. And then you can have a 2-minute break, okay? Any questions on this? Yeah, so you're gonna write it in your notebook, okay? Or on a sheet of paper or something. Take a picture and you're gonna upload it. I'm about to make the Schoology assignment right now.